Okay, so thanks for coming back quickly. And I'll hand it over to Adam Kosmin.
Hello, everyone. My name is Adam Kosmin. I work with Reliant Security out of Manhattan. I've been with the company for 2 years now, but Reliant has been using Puppet for, well, about 2 years now. So those two things probably have something to do with each other. One of the things that I saw very early, I came into Reliant Security kind of waving the Puppet flag, right? I had been sold on the long-term benefits and the merits, really, of configuration management from my previous position. So I walked in with a sense of accomplishment and a sense of confidence using Puppet, really not so much just the configuration management thing, but really more about Puppet's approach, right? The declarative nature of Puppet, and I was a big fan of that. So my confidence came from my previous role where I managed, it was greater than 500 boxes scattered among 3 data centers. Red Hat, RHEL actually, CentOS. And what I didn't realize at the time was that I was basically spoiled rotten. I had it real easy because everything that I was managing were in my data centers. Everything was part of my network. So when I had an update to push or some new functionality, whatever I needed to get out there, it was, and I hope Luke is not in the audience because he'll scream at me, but it was a for loop, and some good old-fashioned rsync goodness, right? So it was very simple. Everything went everywhere, and that was fine. It was a perfect trade-off because nodes residing in data center 1, well, even though their definitions and their data, et cetera, would end up existing, right, in the other 2 colos, it really didn't matter because they just would never get used, right? So took a very simple approach and just pushed everything out everywhere, and that was that. Coming into Reliant, though, I saw some immediate differences, right, where because of Reliant's business model, we're managing infrastructure situated in other people's networks. Very different thing. So what that means is if I had taken my same approach to just push everything everywhere, I'd have to fire myself, right? So a quick introduction to Reliant Security and what we do, right? We take an appliance, a very small yet sufficiently powered computer, and we drop that into a retail location. That small computer, that appliance, is then managed as a Puppet client, which in turn manages several virtual machines. Each virtual machine is then managed as a Puppet client, which then in turn delivers one or more services. These services relate to the PCI initiative, right, to empower our customers to pursue PCI compliance. So services like file integrity monitoring, vulnerability assessment, log forwarding. We even do proxying for public internet access. And we've even get a little creative at times and allow a store to play their music off of our red box. So it's a very flexible architecture. So the problem becomes, well, we don't want to build islands of functionality. It took me only a few minutes to realize that. I don't want to have to run into a client's environment in order to make my modifications, deliver whatever functionality, and then have to retreat from that environment. And when another client needs the same functionality, I don't want to have to recreate that wheel over and over again. So really, this immediately we're seeing that there is a scalability problem, especially when we talk about volume, right? Because even a client that has only a few hundred locations, which is pretty old hat for us, we're talking about at the end of the day, once we consider the additional clients from a virtual machine perspective, we're, even for a customer that has hundreds of locations, we're managing, at the end of the day, thousands of Puppet clients, right? So who here sees scalability issues there? Anybody? Right? And not scalability in the sense, we can obviously have interesting conversations about performance and whatnot and that kind of thing. But again, in terms of overhead, in terms of management, in terms of what does it take to get from development through testing, QA, into production. That's the kind of overhead that I'm going to be explaining to you today in terms of how I approach it and how Reliant Security has approached it. Before I continue, I just want to take a moment to thank Puppet Labs. I've been here all week. I took the developers training earlier in the week. What a great town this is, Portland. I've never been here before. So I really want to thank Puppet Labs for putting together just an excellent format, just an excellent opportunity for us all to come together, share ideas. I've heard a bunch of interesting things, and we'll be following up on some very cool technology. Puppet itself is an important piece of free software. But I think Puppet Labs on top of that understands the value of bringing a community together. So if you could join me for a second, just to thank Puppet Labs. So let's get into these slides. I apologize if you see me trip over anything, it's because my laptop is not in a good mood today with the VGA output. So we're talking about these multiple sites, right? We're going to start getting into the solution now that we've discussed the problem. And what we really want to do is tie this all in together. We want to design a very low overhead distribution model. We want to develop in one place centrally and have confidence that the system that we built is going to pick up run with that and do our work for us. We don't want to translate all that overhead into managing the distribution model, right? We don't want to take one set of problems and just put them in another basket. So what we do here and what we build obviously has to incorporate standards. It has to be flexible. Because the idea is that we want to take on additional sites, right? So it's not just a matter of building a central system and tying all of our existing customers into that framework. We want to make sure that the framework is scalable and flexible so that we can manage this growing footprint. But if we start talking about footprints in terms of analogy, we have to go all the way, and we'd have to say that at the same time, we also have to we have to respect the sovereignty of each toe, right? Toe computing, maybe, right? So multiple sites is, of course, objective number one, the ability to scale in that direction. We want to automate everything as much as possible. We've been saying this all week. Everybody is a big fan of automation. I don't need to sing to the choir, of course. But that, again, just to stress the point, we don't want to sit there and have to push buttons per se to deploy we don't want to micromanage. Certainly at the node level, we're all on board with that. Of course, that's why we use Puppet and other complementing technologies. But we don't want to all of a sudden say, well, we have this excellent distribution system, so it's going to take us a week to get something from point A to point B. We want this stuff automated using a very modular approach, but at the same time, we do not want to treat QA like an afterthought. I've been in many shops where the production deployment is addressed and the production needs are addressed, and then someone gets the bright idea, of course, that hey, we should have some testing here, right? That's usually after something blows up or something goes really bad, and lots of calls at 4 o'clock in the morning. We want to build testing and QA into the system as a fundamental component. We do not want to treat it like an afterthought. So as we progress in this discussion, you will see how I have addressed that. So getting into requirements, I mean, we spoke about the objective. Now to get into a little more of the requirements. Does anyone here use branch testing? Couple guys, okay. Branch testing has been around forever in Puppet, and it is excellent. I've been using it for years now. It doesn't get a lot of attention, although I think it's mentioned in the new Puppet Pro book written by James Turnbull. So branch testing, I think, contradicts environments. I think it's really the alternative way to go in terms of environments. Environments is something I don't use. And branch testing leverages, it really facilitates a workflow, right? So the idea is that you're going to run your Puppet clients against your testing branch, which of course you're going to be committing all of your work into. And once you are satisfied with whatever your testing or QA methodologies are, and you're basically green, at that point you will decide whether or not to merge your code from testing into your production or trunk, right? But maybe you have a separate branch called production, but most people do trunk. So branch testing, I'll get a little more into it on the next slide, just to review for those of you who are already using it, and to maybe introduce for those who haven't. So synchronization is obviously a requirement. This speaks to what we were talking about before in terms of our objectives. I chose a pull-based model. When I found that, in my experience, clients don't like the idea of things coming into their network, right? But yet they're almost nonchalant about things going out, which is, we could talk about that all day, of course. But so realizing that I'm already going to leverage a secure protocol, that being SSH, I had to put some thought, we had to put some thought into whether or not, because again, I was coming from a push-based methodology, right, in my previous life working with Puppet. So I had to kind of flip that on its head and say, well, it's too hard to get clients to really buy into that idea and to start, punching holes in their firewall and things of that nature. And it's just too difficult. So let's not even fight that battle, right? And let's instead flip it on its head. And I believe a pull-based model is very appropriate for this. Another requirement, of course, of the design is to really just follow best development practices, of course. and keep things very don't do that. Keep things very modular. Don't do that. Keep things very modular because your requirements are going to change, and I'll show you an example of how. Well, what we're looking at today is really the first iteration of this design. We don't actually use this current design. It just doesn't fulfill all of our requirements that we've learned about, through our dialogues with our customers. And by having that modular design and really breaking out functionality into various pieces and various stages, what I've found is that there's always an appropriate place to satisfy the latest requirement. There's always an opportunity if you've structured that very well. And some of the, again, because here we are on day one of this design, our modular design needs to be, we have to think of it still at a very high level, right? And we'll grow to understand exactly what the intricate details of those components are as we get to use the system and give more thought to it. But at a very high level, when we're talking about these requirements, it makes sense to think about, the whole master-slave thing. That's pretty obvious. So in my talk today, I'll be talking about Puppet masters in a very different sense than I know the community thinks about Puppet masters. A Puppet master in this world, of course, is a server running the Puppet master D binary, right? Or in the 2.6 branch Puppet master. My Puppet master is just an over-glorified file server. That's it. The next piece of new terminology, so Puppet slaves, these are Puppet masters, right? These Puppet slaves will, of course, also be Puppet clients or running, the agent. And they will actually compile against themselves, right? Loopback, et cetera, and they will configure themselves to be Puppet slaves and everything that it means to be a Puppet slave, right? So, basic requirements: branch testing, synchronization, modular design. More into branch testing. I saw just a few people who raised their hand. This document is up on the wiki. It's up on the Puppet Docs wiki. It's been there for a long time. And it walks you through step by step how to proceed, how to, I assume, of course, that you're using a version control system that supports branching and merging. The assumption, of course, is that you're using Puppet in a client-server fashion. You're not compiling manifest locally, right, with the Puppet apply, et cetera, and that you have a working directory. Though they recommend etc Puppet, but the branch testing documentation we follow that instruction or that set of instructions, and we actually place these into more appropriately named locations like etc.puppet.production, right, or etc.puppet.testing, or maybe you have a dev branch, or maybe you have a hey, this is the coolest thing ever branch, or whatever whatever works for you. So the idea, again, going into the workflow, we always commit into testing branch. We do whatever syntax checking, of course, at that very high level. We always put our newest stuff in the testing branch. Then what we want to do is we want to synchronize our our testing branch. Now, this doesn't get into the segmentation, of course. This is really just, we're just talking about branch testing in general, right? So at some point, we need to get a copy of that testing branch over to the remote instance of the Puppet Master. At that point, we want to fire up an instance of Puppet Master D against that working directory or against that copy, right, of your code. But you want to run it on a non-standard port because you can't run it on port 8140. Your production instance is already listening on that port. So you want to run it on, 8141 is fine. This, of course, is going to be something that you'll need to communicate probably into your clients. You'll need to talk to them so that they allow that traffic, right, from the clients. If they're doing anything with their firewalls and ACLs, et cetera, they've already carved out a niche for traffic from your clients to your Puppet Master and port 8140. You want to accommodate this or for the additional traffic beforehand. That's the trick, right? Not when you can't telnet to port 8141. So when we're satisfied and we've run that Puppet agent against our testing instance of our Puppet source code, I like to utilize no-op. I'm a big fan of no-op, right? Looking into the future kind of thing and seeing what would break. That's going to solve 99 point some ridiculous number of nines QA tests in my experience. But not to say there aren't other significant strides to be made with QA. So I'm a big fan of no-op. And once you're satisfied at that point, you'll have an opportunity to merge your testing branch into trunk, which can get interesting. Don't get me wrong. That in itself can be interesting. But there's, of course, the red book if you're using Subversion, right? So let's talk about, we've identified the requirements, pretty high-level requirements, but let's start to conceptualize how to realize those or how to pursue those requirements, again, just at a very high level. With the synchronization or the replication, everything is there. We can, and this is the best part, everything here is very simple. This is not, some bleeding edge technology with the coolest name ever that's up on GitHub that you're going to have to spend the next 2 weeks learning about, et cetera, et cetera. Not to say there's anything wrong with that. But this stuff is low-hanging fruit because everything needed to fulfill the first requirement is already available, right? We know what a file resource is. We know what, a file resource, of course, to create a script that can be constructed off an ERB template, which of course would be structured or rendered dynamically according to the site. And I'll show you that. We'll walk through that. We know how to leverage the package resource, right, to ensure that rsync is even available, right, so that work can be done. So we know how to leverage the user resource, right, so that we don't do everything as root, of course, right? So we have a non-privileged user that's going to run a script, that's going to call a binary, and et cetera, et cetera. So all of this stuff is already low-hanging fruit. It's available in Puppet, and we can use these very, very simple building blocks to pursue this unit of work, right? We have to think about security, of course, all the way through. We don't want, right, we're good sysadmins. We don't want to treat security like an afterthought. So I'm a big fan of leveraging the command directive of a user's authorized_keys file. I'm a big fan of managing, of course, the config file, SSH or .ssh config to require, of course, version 2 of the protocol, and these kind of things. So I'm not going to get into how to set that up, the command directive. Everybody knows what I'm talking about here, right? Show of hands, everybody uses that? Good, okay. But I did provide a tiny URL because when working with rsyncs, you do have to kind of debug the output to see exactly what the command is. So it can get a little verbose and whatnot. So please follow up on that link. So the last of our requirements, the modular design, I thought I would draw a picture. So we have our little sysadmins up there, right? And this tries to explain the workflow, really, where they're not going to be calling native SVN commit commands and whatnot. Instead, we're going to wrap all this up into a script. It's a much better way because you can solve many other requirements that you're going to learn about as you make progress in this direction. You're going to be able to wrap, of course, again, your syntax checks, right, against your Puppet manifests. You're going to, all of your input validation, whatever that ends up being for you, is going to be wrapped up in whatever your favorite commit script is, whether you want to do that in Ruby, a Bash shell, et cetera, et cetera. I'll show you later a very, very stripped down version of a commit script that shows you exactly how that validation, right, is performed. Again, it'll be very stripped down because I needed to strip out all the Reliant specific bits and whatnot, of course. So your commit script is basically going to handle the job of getting your stuff into your version control system, whether you're using Git or Subversion, et cetera, et cetera. And then what it's going to do is it's going to update on your Puppet master, your over-glorified file server, of course, right? It's going to basically just do SVN ups. I'm speaking Subversion because that's what I use, but translate that, of course. So it's going to do an SVN up, is going to update local working directories of the branch that you're working with. In this case, we're assuming that's going to be testing. And then what it's going to do is it's going to sudo over to an appropriate user. You'll see that we're going to end up with multiple users. There's a one-to-one relationship, one user per site. Okay, so every site gets a home user with a local user. It could be remote, of course, but there's that one-to-one relationship. So the next thing that your commit script is going to do is to update the non-privileged user's home directory with an up-to-date copy of the working directory. Okay. That local user is going to also be furnished with appropriate SSH bits, right? So an appropriate public key and authorized keys, and this gets back into our discussion about how to secure that with the command directive, et cetera, et cetera. So everything I just talked about is this idea of the Puppet master, right? So later on, we'll construct or we'll write a Puppet class that creates that Puppet master. And so this is just a high-level overview of what the expectations are of that Puppet master. It's pretty simple. The more interesting set of functionality as it relates to this entire framework here really ends up residing on the Puppet slave, right? Because the Puppet slave is actually going to do all the grunt work. He's really going to drive this. So for him, There are a couple of elements. The first, of course, starts with a local user. Appropriate SSH bits, right? So that he can have that handshake. We're also going to furnish our Puppet slave with yet another script. Again, whatever you prefer. Your Ruby script, I like Bash. It works for me. And that script is going to be an rsync script, right? Who obviously his job is to connect to the master, the file server, and rsync the diffs back over. So this, of course, is going to relate to every branch that becomes relevant in your environment, right? So if you end up supporting or working with 4 branches, your rsync script should accommodate those use scenarios. It should not be flexible. It should not be the kind of thing that can be that needs to be typed in manually, because we'll see that, well, moving on, there's going to be another script that the Puppet slave is furnished with, which is, again, is going to be a dead simple, very basic script that all he does is fire up a WebRick instance. Because in production, you're probably doing very cool things with, Apache or Nginx or Passenger or, all these really cool things to address your other scalability issues. But when it comes to testing and these one-off runs that you need in order to build confidence that your code isn't going to blow things up and that it actually does what you think it's going to do, you don't need all that power. You don't need to set up, you don't need to do all that hard work again in terms of tailoring Nginx configs and tweaking, passenger variables and whatnot. It's just too much overhead. You don't need all that. What you do need is just a very simple daemon like WebRick fired up on your non-standard port, so that the Puppet client can connect to it. So that was part 1 of the presentation. Things may move a little slower now. I had my laptop with, of course, all my VI buffers in order, because I'm wanting to walk you through some of the code that actually that actually is used to create all this. So instead, I'm going to have to, we're going to look at GitHub. And I do want to mention that everything, the presentation, even the LaTeX file used to create the presentation, and all the code that we're going to look at, this is all up on GitHub. Okay, it's GitHub / Reliant Security. So the first thing when we reflect back on the workflow is the commit script. Before I show you the commit script, very simple little database, if you want to call it that, right? A little variable is assigned. This becomes very interesting later on. I'll show you an example of how we learned a new requirement, driven, customer driven, and having an opportunity to realize what sites are eligible for this replication and whatnot became pretty significant. So everything starts with your commit script, right? Basic scaffolding, usage, et cetera, we want to check our input. For me, it just became a matter of knowing if I intended to work with the testing branch or the production branch. So I'd give it a -T or -P, whatever. Don't worry about the N. I added that because I thought I would actually run the script and show you some things, and I wanted to essentially no-op mode. But the idea is that you're deciding what branch you intend to work with, right? And we can see that based upon that intention, we start learning things about what working directory we're going to later update. You'll see that on line 38. So you set your work there to the appropriately named directory. And then we simply do our commit. Again, this is very stripped down. You're not seeing a lot of the input validation that you have an opportunity to pursue here. So keep that in mind. I just wanted to keep it short and sweet for the purpose of this demonstration. So this is doing exactly what we said it would do. It's updating the working directory on the Puppet master. And then you'll see on line 46, we sudo to the appropriate user, and I'm sorry, that's actually our commit. But now down here on line 54, we start constructing. This is where all the magic happens. This is it right here, one line. It's dead simple, because we have a working directory in our etc puppet.testing, which now contains all of the data, all of the node definitions, everything for all the sites you're supporting, all the remote locations you're supporting. We need to carve that up, right, so that we can make an appropriate portion of that available to any given site. So on line 54, this is where all the magic happens. We build an appropriate rsync command using its ability to include and exclude. So we start filtering right here. If you look at this, you will see that I intentionally took kind of a default deny approach, right? I basically exclude everything and then only include things that are specific to a site. Now, maybe that's debatable. Maybe someone wants to take kind of a default allow approach. We could debate about that. We could arm wrestle about that, et cetera, et cetera. We build the rsync command, and then finally on line 56, we run the rsync command, and we end up, you'll see its target is the site-specific non-privileged user. So we end up with a carved out instance of that working directory that only contains site-specific data and files and whatnot. And the reason this works is because I'll be able to show you this as we move on with this GitHub representation. The reason this works is because we discipline ourselves. This goes back into what I was saying earlier on about the modularity and the need to build scalability into this. So what we've done is we've disciplined ourselves to using a directory hierarchy that can accommodate this. So we don't have a file. We never want to end up with a file that has big old glorified case statements in it, or if-else statements, or any one of these kind of things that says, if your site foo, do this, and then else, if your site bar, do that. That's not good, because it's much harder to parse a file for relevant information that you're interested in. It's much easier to just include or exclude a directory. Then you get all that for free. So you need that discipline up front. And your directory structure needs to be thought about in advance in order to empower yourself to do something like this later on. So let's see. Okay, I figured out how to go back. That's good. Okay. So everything starts with the commit. We know how files and how manifests and how modules and how data and relevant other relevant bits are now being published, but that doesn't mean that they're going to be used. So this starts happening very quickly. I'll show you. We'll start at site pp. Everybody has a file named site.pp. All the magic starts there. Just some global overrides, nothing anybody hasn't seen. This is where we start pulling stuff in. This is where we start benefiting from that directory hierarchy that we've disciplined ourselves to. We import all these relative path, these nodes. We're importing everything. We go into the nodes, and we see they're carved out by site. And in these files, I've settled on these naming conventions. It works for me. I have nodes, I have roles, and I have styles. What I like is the idea that every node, every client is going to inherit a set of variables, which of course can benefit from inheritance, right? Because I don't want to have, I don't want to repeat myself over and over again. And then every client is also going to inherit what I call a role, right? But a role is really just a class, and a style is just a node, right? Everybody has worked with this, so we just create node definitions with styles, and these styles just contain, wow, my tabs are really off. They just contain variables. And I've found that to be a very easy and almost mnemonic way to structure these things, and it translates very easily. So let's look at a role for something that we would call a puppet master, the first kind of object that we want Puppet to construct. Right? We don't want to build a puppet master manually. We want Puppet to do it for us, right? So the node that ends up inheriting this class via its role assignment, again, you see the inheritance here, so we don't have to repeat ourselves. He will include this puppet master class. We'll go back up to this. And again, I'm sorry for the delay. I did not intend to have to use a browser to navigate this stuff. Sorry, I want to go in my module, my Puppet module. We're interested in the master class. Okay, just some inheritance. We have a simple define down here, a simple definition. All we're doing is creating a user. You can see that we call out to another external module that handles how to construct our users. I'm sure everyone has their own account module, so I didn't try and make this too specific to my environment. And all we do is for each site, we build one of those users. Right? So we saw two sites before, for example, purposes, EX1 and EX2. At the end of the day, my Puppet Master is going to offer two local users that are constructed using the naming syntax I've settled on rsync site name. And their SSH bits are going to be, of course, managed, as you can see. Again, don't forget to go the extra mile, right, when it comes to the command directive and managing the configs. So that's our Puppet Master. We just built, if we think back to that picture where we had the large visual of the Puppet Master, we just built it. It was that simple. Now we want to build a Puppet slave. Again, this is more interesting. I won't walk you through the node inheritance anymore. We saw that. The same logic follows, the same conventions follow. There's going to be a node, of course, or multiple nodes, depending on your needs, that utilize this Puppet slave class. You see another file in here called server. That'll make sense in a moment. So our slave does some things. We want to make sure that we're also managing the client on the slave. Of course, we follow our best practices and we modularize that, and we have another class called Puppet client. So you can see the slave includes that. I should have stripped a few more things out of here. I don't know if you're interested in using passenger, but you get the idea. So again, we go and create the same user. We do the same thing. We ensure the rsync package exists. And then here's the reference to the server I was talking about. Early on in designing this, I realized when we think back to what we were saying about maybe you're running passenger for your production instance, maybe you're running Nginx, maybe you're doing something else. It's easier to break that out into something called a Puppet server, and then just be able to call upon that using attributes. So it's best to design, I think, this whole idea of what a Puppet server is relative to each branch that you will associate. It's easier to carve that into a definition than it is to hard code it into your class. So that's exactly what I did. I won't show you the actual server define. Okay. But you can see that I'm calling upon it twice. I have a production instance of the server, and I have a testing instance of the server, or trunk. Or that could be a typo. It's a typo. Should be testing. I'm out of time, but quickly we see that we start managing our SSL bits relative to each server instance, whether we're talking about production or testing. And down here is where the magic happens in terms of those scripts that I was calling your attention to before, the rsync stuff and the WebBrick instance. Those are both ERB templates, of course. That makes sense because they'll be rendered in accordance to the site that you're managing. That's it. I'm out of time. But all this stuff is up on GitHub, and my intention, of course, is to make it available so you can get a better idea of whether or not it'll fit your needs. That's it. Thank you very much. Of course, if anyone has any questions, do we have time for that?
Time for one question.
We have time for one question. It's got to be good, I hope. Okay. Yes, sir.
It's really complicated to me. It's just kind of a comment, but oftentimes Puppet, I've seen it as a simplicity system. But I'm starting to, I didn't quite see where you were going in terms of, but I know that the domain you're trying to solve is very different than maybe what a typical Puppet.
Right. So I believe it's actually very simple because the tools, if you understand, if I've done a good job of explaining my mission, which is to strike a balance between centralization and segmentation. So to have everything kind of tied into the mothership, right? But at the same time, provide sovereignty among each site that is part of the overall assimilation. If you understand that objective, or if I've done a good job of explaining that, well, so what we did was we kind of walked through how to construct that, and everything needed in order to construct that and have Puppet manage it in a hands-off fashion. That's the idea. I don't want to have to sit there and push buttons all day. So what we do is we design into Puppet and we tell it how to create a puppet master and how to create a puppet slave. And these fundamental building blocks take care of that workflow. So that's why I really wanted to get this stuff up on GitHub and give you an opportunity to, point your browser to the site. It's github.com Reliant Security, because it's tough to look at code up on a big board like this and to absorb it all like that. I hope you'll see that it actually turns out to be dead simple, very simple. But feel free to reach out to me, Adam Kosmin at Reliant. I'm on IRC as Windows Refund in Pound Puppet on Freenode. I must know some of you. So that's it, guys. Thank you very much.
Okay, we'll have another short break now. Next up in here, we've got Kelsey Hightower talking about puppet faces. And in the other room in the cloud track, we've got Chad Metcalf from Cloudera talking more about Apache Ware. We'll probably kick off in here in 10 minutes. The other room probably will start in 5 minutes. So make your decisions.